Hey guys, it's the Jellyfish software team here, and we got a request to show people how Encoder worked. And since we don't want to leak our private secrets, we made this for just for you guys. So basically, this is a very simple encoder thing, and it has all the functions. Right now, if you put this and run it on a robot, it'll do nothing because there's nothing here. But yeah, so currently, we have everything declared for our robot. You'll need this part may change for your robot because you'll have different hardware than us, and you'll need to import stuff obviously. So let's move on to this part of the code, which is what really matters. So for encoder drive, you need to make sure first of all that the encoders are attached to your motors. So we'll show that later in the video. But so first I made a very simple function. It's a void called vertical drive. And you put in a power and it sets the motors to these powers. So you use that because you don't want to write this again because you're lazy. So yeah, in your next function, it's the distance part. So this is the one you're going to use to actually move your robot because this just sets a power. It doesn't set it back. It doesn't do anything. So you have a double power because power is always in a decimal, and an integer distance because it's number of encoder ticks, and you can only input in integer. So yeah, and first of all, you want to stop and reset your encoders. So basically, if you for every time you use this, it'll reset all the encoder values to 0. So like if it already moved prior, it won't mess up. So this is very crucial. And then it'll set up target position, which is distance. And what this will do is basically this is the number of ticks on the encoder you'll want to move, and it sets that target position. And then you have to set it to the run mode, run to position, and then you give it the amount of power you want. So essentially what this will do is this will run it it will drive forward until every single motor hits that target distance. And yeah, and this while loop is just to make sure that when you nothing else can run while you're running this. So yeah, and after that you set the power to 0 to break it, to apply brakes. So yeah, it's pretty simple. And so the way you implement it is, let's say you want to drive forward for 2 rotations. So you do vertical drive distance, and we have the rev for revolutions for our motors up here in a variable for convenience. It won't be 1120, so you should check the website of wherever you ordered your motor from, and it'll show encoder ticks. So you'll want to first do the power because that's how it's declared. So I want to move it at a power of 0.7, and then let's have it move 2 rotations. So you do 2 times rev. Right? And then after that, let's say we want it to go back the same distance. So we're going to make the robot stop everything for 1 second. So sleep. And then, so the way you make it go backward is you have a negative power and a negative distance. So you do -2 times rev. So yeah, it's pretty simple. This is all you need to do. Just remember that you need to reverse the motors if you have to, depending on how your motors are put on your robot, and declare everything properly for your robot.
Okay, so this is our robot, and I'm just going to show you what the encoded wires are. So if you see the motor, you see the red and black power pole wires, which connect it to this rev expansion hub. And you also see this green, yellow, black, red wire. It's the encoder wire. You can see it connects to these glowy things, which connect to that. So yeah, you'll want to have these attached, otherwise the code won't work and it'll be bad.
Okay, the encoders are plugged in between the plugs for the motors. See, like this one right here.
3, 2, 1, light it up!